Hi, one of the things you're going to have to think about if you're going to use off-grid or even vehicle-based solar panels is how you're going to wire them. So once you've chosen whether or not you're using flexible panels or fixed frame, how are you going to put them together to give you the voltage and current that you need to get the best charge on your batteries? There's a couple of things to consider here. First of all, how high you want the voltage to be. If you go too high on the voltage, it can make it problematic to choose equipment for the actual DC lines. So, for example, most inline circuit breakers are rated for 12 or 24 volts, and it's going to be much harder for you to find 36 volt or even higher voltage circuit breakers for your installation. So, depending on how much research you want to do, you want to choose your voltage that you're going to be working at accordingly. The other thing to bear in mind is all the voltages are nominal. So a 12 volt panel, for example, will have a open circuit voltage between 17 and 21 volts. And you could double that up for 24 volt and add it on again for 36 volt systems. However, if you're using Victron Energy MPPTs, you'll find that they will only start to charge a battery when the voltage of the panels is consistently 5 volts above that of the battery itself. Therefore, if you work in high voltage, you'll get a longer charge cycle working in high voltage than if you would if you use a short voltage. The other thing to bear in mind is that you've got higher efficiency working in a higher voltage. So fewer amps going down the cable means less resistance. Less resistance is less loss of energy as heat in the cables, and therefore the whole system should work more efficiently for you. So if we think about how we're going to wire these panels in, my advice to you, based on my own experience of trying both parallel and series connection and also series parallel, is that you stick with series parallel in high voltage. So for example, if you've got a 12 volt battery to charge, then you might want to go for 3 panels in series, giving a nominal 36 volts. So if we draw our 3 panels in series here, you can see that you go the positive of one to the negative of the next, the positive of that to the negative of the next. And we link these across, sometimes known as daisy chaining. We link these across, and that gives you a positive out to your solar charge controller and a negative out to your solar charge controller. Remember, I'm just doodling these drawings here. These cables, the positive line and the negative line as well, they both need to be the same length in order to ensure that you've got no uneven balance in the system. And that's the same for the cables going from the controller to the batteries and from the batteries on to the equipment that they're running. So try and make sure that your cable lengths are the same, even if in reality they don't need to be. So you may have, for example, at one end of your panels, you've got your controller. Well, you're going to need to create your positive line, in this case, the same length as this one, and then just curl the wire up, taking care, obviously, that you don't create pockets of heat in the system. So that's an example of series wiring. What do you want to do, though, if you say you want to work at 36 volts, but you would prefer to have another line of them in parallel? Now, there's 2 things to consider here. Paralleling wires, you use splitter cables. So, for example, if I was to have another set here, and we series those together, we've got these positive here and the negative here coming round. Now I've got 2 negatives and 2 positives to bring together, and your Y splitter is what does that. So that's a Y splitter point there. Okay, and that's using an MC4 connection. Now you need to bear in mind, usually MC4s have a maximum amps rating of 30 amps. So when you're choosing how to do this, you need to think about the maximum rating of the weakest point in the system, which in this case is going to be your 30 amp MC4 connections. So up in voltage, down in amps, and that just means that you can get the higher the voltage, the more panels that you can get on the string. So here's our other Y splitter. That gives us a negative and a positive going to the controller. Now, the problem with this is you can't always have two rows of panels that bring your wiring to the same position. So I got around this by putting my units in separately to each other. So in other words, I created a group of 3 in series like this, 1, 2 to 3, and then I've got my positive off at this end and my negative at this end. Now, a Y splitter, to avoid using extra cable, which is expensive, it's about £1 a meter at least, here's the way around it. What you then do is you drop in your second set of series wired panels into the gaps between your first set. So this was going off here. So now I'm going to go, okay, here's my 3 additional panels. I'm going to go from one to the next, to the next. Now I've got my negative here and my positive here. And the Y splitter, the paralleling point for the two systems, is then within reach of both panels at either end without using additional cable. So that's a little trick for you. And the wire on the back of Victron solar panels, for example, is just long enough that you can make this jump with a panel in between. This is using the 175 watt panels without putting too much strain on the cables. It is important though that you cable tie them in so that the connections aren't bearing the load of the cable, and also the vibration and wind movement of the cables, which can damage them. So if you're going to do series parallel and you can only got space for one row of panels, drop them in between and you'll be able to reach the wires without having to create an additional wire to extend this section here. That might be my top tip for you. So best of luck with that. Hope it works out for you. Remember, do it safely, and if you're not sure, get qualified help.